geometric progression. Don't see that. See here. We are going to start geometric progression. This is another type of progression, another kind of sequence. This is it is a sequence in which the ratio of a term to its predecessor is the same. If the ratio of a term and its previous term is the same, then that sequence is said to be geometric progression. Is said to be geometric progression. We can see example. Example is 4, 8, 16, 32, 64, and so on. This is a sequence. This also follows some kind of pattern, right? And if the ratio of any two consecutive terms, ratio of a term to its previous term is same, then we can say the sequence to be geometric progression. We can see the ratio of these two. When you divide 64 by 32, when you make the ratio is a kind of division, right? So when you make a ratio with this and then its previous term, then it comes as equal to 2. The ratio of these two also is coming same as 2. The ratio of these two consecutive terms also comes same as 2. So when we are making the ratio of a term with its previous term, then it is always coming constant. Such sequence is said as geometric progression. Such sequence is said as geometric progression. Is it very clear?
Yes, sir.
Same like arithmetic progression, here we also will begin with nth term. We will begin with nth term. And the formula for the nth term is Tn is equal to ar to the power n minus 1, where a the first term, r is the common ratio, n is the number of terms that we are going to calculate. Is it very clear?
Yes, sir.
With this, we can begin the exercise. The first question is a very simple question. Are we in exercise 1C?
Yes.
Is it 1C? 1D. That's why I'm asking you repeatedly. Okay. So, the first question we have is, find a given term of the given sequence. We are taking the example number B, 1B. In this, the series is 1 half, 1 over 2 square, and so on. This is a sequence, and the question is to find the ninth term. Question is to find the seventh term. That means n is equal to 9. I said I'm going to do B. A is very simple. Okay. Now we have the number of terms for which we are going to calculate. And we are going to calculate ninth term. The sequence is given. So it's very easy for us if the sequence is given. We can have the value of A and the value of R. A will be the first term of the sequence, and this is equal to 1. And R is the ratio of a term with its previous term. So better to have the ratio of these two because these two terms are very simple, right? And therefore R is equal to half divided by 1. Will it remain as R? Half? Is it okay?
Yes, sir.
Any number divided by 1, it remains as it is. So now we have all the things, we can easily calculate the ninth term. So use the formula T9 is equal to A1 into R is half to the power 9 minus 1. This is equal to 1 over 2 to the power 8. Because actually numerator also will have the power 8. But giving power to 1 is of no meaning because it will still remain same. You give any power to 1, it always remains same. So that is why I am not writing any power of this one. It does not mean that there is no power of 1. Is it understood?
Yes.
After this we can simplify. So we have 2 to the power 8. You can use the calculator. 2 to the power 8. It is coming to 56. It is coming to 56. That's all. So this is your ninth term. Is it understood?
Yes,
The question is very simple.
Yes, sir.
Thank you. Okay. 2. Question number 2. The second term of a GP is 18. The second term of a GP is 18. And fifth term is 486. Let us write this. Second term is 18, and fifth term is 486. Is it the fifth term?
Yes, sir.
Okay. So with this two information, we are asked to calculate the first term and the common ratio. So what we can do is, we can use the nth term formula and expand it. Is it okay? So this can be written as AR, because the formula is AR n minus 1. This is equal to Tn, isn't it? So putting the value of n in this formula, you are getting AR for T2. And this is equal to 18. Likewise, for this we will get AR to the power 4 is equal to 486. Is it very clear?
Yes, sir.
We will name this as equation number 1 and this as equation number 2. Is it okay?
Yes.
This equation belongs to geometric progression. So whenever we have to calculate A or R, we will use the concept of divisibility. In case of arithmetic progression, we use the concept of addition. We use the method of elimination. Do you remember?
Yes, sir.
So that is the difference between AP and GP. So here we are going to divide equation number 2 by equation number 1. If you divide equation number 1 also by 2, you will get the same answer. But normally the practice is, we used to keep the higher order in the numerator and the lower order in the denominator. Is this okay?
Yes, sir.
So dividing equation 2 by 1, we get what? AR to the power 4 is equal to 486, and then divided by this side AR, and this side divided by 18. Is it okay? Can you help me? 486 divided by 18 comes how much? 27. Thank you. Now this A will cancel this A, and this R will be cancelled, and this R will reduce by 1. So this becomes to the power 3. So finally we are left with R cube to the is equal to 27. And finally this cube will go to right hand side, will turn into radical sign. Is it okay? And that's how we will be able to get the value of R. And therefore your R is equal to cube root of 27, and this is finally equal to 3. We got the value of R.
Yes, sir.
Now if we can also have the value of A, our job is done, because we are only asked to calculate the first term and the common ratio. Common ratio is calculated. So we can find the first term by putting it in equation number 1 or in equation number 2, anywhere you want. But why to take trouble? We will go for equation number 1, more simpler. So putting value of R in equation 1. So A into R, R is 3, is equal to 18, and therefore your A is 18 divided by 3 is equal to 6. Is this question very clear?
Yes, sir.
Any doubt?
No, sir.
We'll continue. We will go to question number 3. Question number 3 says what? The fourth term of a GP is greater than the first term, which is positive by 372. The meaning of this question is, the fourth term of a GP is greater than the first term by 372. It's very easy to understand, no?
Yes.
Is it okay? Suppose this girl, two of us have some money, right? Obviously she will have less money because father gives only 50 rupees or 100 rupees. And I being a father, I will have more money. So the difference of our money is suppose 100. Right? What do we understand? If you find the difference of these two, then you are getting the result as 100. That's the meaning of difference of 100. So you subtract her money from my money, and then you get the result as equal to 100. Is it okay or not? So similarly here, the fourth term is greater than the first term by 372. That means the difference between these two terms is 372. So we can use that concept and write third term. Is it third term? Fourth term is greater than first term by 372. Fourth term is greater than the first term by 372. Is it okay? And another part says the third term is greater than the second term by 60. Third term is greater than the second term by 60. Third term is greater than the second term by 60. These two are information. These are two informations. Now we are going to elaborate this using the nth term formula. So you know now how to write this value of T4 and how to have the value of T1, T3 and also T2 using nth term formula. AR to the power n minus 1. Is it very clear?
Yes.
So using that we can rewrite this as AR to the power 3 minus A. Very good. Thank you so much. This is equal to 372. And then finally, can I take the common factor A?
Yes, sir.
This is R to the power 3 minus 1 is equal to 372, and I will name this as equation number 1. This we can remodify. We will write this as AR to the power 2 minus AR is equal to 60. And here also we have some common factor. We'll check it out. AR out. From here you get R. From here you get minus 1 is equal to 60. This we will name as equation number 2. Is it okay?
Yes, sir.
Can you first of all complete this one because I need this side also. Okay, from here we are going to continue now. After we have done this, I gave you the concept in the first question that this exercise, all the questions will be done by using the concept of divisibility. So again I am going to divide one equation by another equation. Again I tell you, you can divide any equation by other equation, but always give the priority to the higher order to be in the numerator. You will be at the safer side. Is it okay?
Yes.
So this is of higher order. Do you agree with me?
Yes, sir.
So this equation is going to be divided by this equation. So dividing equation 1 by 2, A into R to the power 3 minus 1 is equal to 372 divided by this side, AR into R minus 1, this side divided by 60. Is it okay?
Yes, sir.
Now what I see here is A cancel this A, 12 5s are 60, 12 3s are 36, 1 12, 1 2 12, 12 1s are 12. Is it okay? So this I could simplify. This part is simplified. Now many of us do mistake of simplifying this with this. It's a binomial. Binomial cannot be done that way, right? A part of a binomial or a trinomial cannot be simplified with the numerator and denominator. Is this okay? Only this that can be simplified if they are in the factored form. If they are in the factor form, like this A and this A are in the form of factor because this A is multiplied by this. This A is also multiplied by this. So this A and this A are in the factored form, and they are free, bachelor. So they can be simplified. Is it okay? But this part not doable. Not doable. So now what we can do for this part? Are you getting me?
Yes, sir.
For this part we need to have a concept. A cube minus B cube. Same as A square minus B square. This is also A cube minus B cube, and this we will call it as difference of cube. We will call this as difference of cube. And we will have the factor for this difference of cube. We have factors of difference of cube. Please turn this side. You turn this side. Is it okay?
Yes.
So we will have the factor of this, and the factor of this is A minus B into A square plus AB plus B square. This is the factor of A cube minus B cube. Is it okay?
Yes.
To make this work more easy, how I see this two term, this base I see as the first term. I'm telling you, I see this base only as the first term and this base as the second term. So when I say first term, you have to see A, and when I say second term, you will see this another base B. Is this okay? And then you are writing the result. So the result is first term minus second term into square of the first term plus product of first term and the second term plus the square of second term. Because if you say in terms of first term and second term, then in place of A and B, if you have something else also, you will be able to interpret. You will be able to interpret. Are you getting me? So I am going to use this concept in the numerator. I am comparing this with the numerator. Are these two same? Is this and this same? It does not look like same, but it is same. Why? Because the first term is cube, we can see. And this second term, though it is not cube, but it can be assumed to be a cube. Because it is 1. And I always say, in mathematics, 1 is God. You can assume it anything for your purpose. You can use this one in any way you like. Is this okay? So for me, I can see this also as cube. So I'm not going to write, because if I write, after some days, you might think that from where this one 3 came. Is it okay?
Yes, sir.
So I'm going to factorize this part using this concept. So this will be first term minus second term into first term square of the first term plus product of the first term and second term, that is 1 into r, so r, and then square of the second term, that is 1 square means 1. Is this very clear?
Yes, sir.
Denominator as it is r into r minus 1. This is 31 over 5. Now after doing this, we can see now this and this factor has become common, so they can be simplified. This is now cancelled. Now numerator you have only r square plus r plus 1, and denominator you have only r. That means ultimately on left hand side we have only one fraction, and on right hand side also we have only one fraction. In that case, if you have one fraction on either side of equal to sign, we can go for cross multiplication. So now we are going to do that. So start now. 5r square plus 5r plus 5 is equal to 31r. Am I clear?
Yes, sir.
Now I will take this also to left hand side, because this and this are same. So they can be together, simplified. So 5r square, when I bring it here, 5r minus 31r will become minus 26r plus 5 is equal to 0. What kind of equation is this now? Quadratic equation. You know how to solve this quadratic equation, right? So we'll factorize it. 5r square minus r minus 25r plus 5 is equal to 0. Do I have to explain you? The product of the first and the last term is 25r square. When you multiply these two also, you are getting the same product, 25 square, because this is minus, this is also minus, minus, plus. When you are multiplying, we can use the sign rule. We can use the sign rule. Is it very clear?
Yes.
And then the sum of these two also is same as middle term. So this is the right expansion rule.
Yes.
Now we can do grouping. This and this can be grouped together. From here you are getting r out. Then this is 5r minus 1. And from here you take out minus 5 common. This becomes as 5r, and this becomes as minus 1 is equal to 0. So finally we have 5r minus 1 and r minus 5 is equal to 0. So from here we can have the value of r. Is it okay? We are going to get two values of r. So your one value is 5 and another value is 1 over 5. You got one value for a? No. So far we didn't get the value of a, no? We got only r. Now what we need is, we need to have the value of a. Is it okay?
Yes.
What was the question? The question is to only find out the first term and the common ratio, right?
Yes.
So we got the two values of r, that means we will get two values of a also. So we'll find out. Now, for that, we can use one of the equations to find the value of a. Wherever you want, you can use it. Can I go for this? Is it okay? I'll go in the first one, right? Okay? From anywhere you will get the answer. So if R is equal to 5, okay, then putting value of R in equation 1. Your equation 1, A into R is taken as 5. So 5 cube minus 1 is equal to 372. Is it okay?
Yes.
This implies 5 cube is 125. 125 minus 1, 124. That 124 goes to that side, will become a denominator. So your A will be equal to 372 divided by 124. This is equal to 3. So you got one set of answer. When your A is 3, your R is 5. Are you all satisfied?
Yes, sir.
We are now going to find the value of another set. Again, similarly. This is the notation for similarly. Okay? You draw two parallel lines and then write LY. This is similarly. Is it okay? So your R is now 1 over 5. Put it again in the same equation. A into 1 over 5 cube minus 1 is equal to 372. Is it okay? This will become A, and then 1 minus 125 over 125 is equal to 372. Am I right? This will turn into minus 124. Minus 124. So therefore, your A will be equal to 125 into 372 divided by negative 124. So 124, 3 are 3 into this minus 375. Is another value of A is minus 375. If you have doubt in any step, please ask me. The question is little lengthy. That's all. Any doubt? Thank you.